first one is, say, GS equal to 1 over S. Okay? So again, here we're still under the complex plane, so that means the Gj omega equal to 1 over J omega. So again, if you like to tabulate, and you can say, so the magnitude and the phase angle equal to minus 90 degrees. Okay. So from here, if you like to tabulate, you're starting from omega equal to 0, then basically this approaching to infinity, this is 90 degrees. When omega equal to omega 1, basically omega 1 over, and then go to omega go to infinity, this is 0. So, but this is always 90. Okay. So for this case, then you can plot it very easily. So this is a complex plane, and the real part of the G, J omega, and this is a major part of the G, J omega. It's always been a good exercise when you plot on the complex plane. You indicate that complex plane is for which functions. Okay, so here we kind of emphasizing here. So now for this one, basically the phase angle is always minus 90 degrees. My drawing is not so correct. So when 0, that is here. Okay, so basically that line is going up to here, and always 90, so approaching is to here. Okay, so that means the trend is this, and I would say this one is omega equal to 0 down the very bottom there, and approaching to here, that is omega approaching to infinity. So that is the one for this. Okay, and now the next one. Gs will be equal to 1 plus Ts. So Gj omega will be 1 plus J omega T omega. So again, the magnitude equal to 1 plus T omega square, and the angle equal to, this angle is equal to 0 degrees numerators minus the degrees of the denominators, okay, T omega. So basically this one equal to minus, we just keep it, basically this one is minus. Okay, so now we can tabulate. So when omega is very small, so say omega almost equal to 0, then the magnitude equal to 1. Okay, and then for omega equal to 0, basically this is minus, how much is this one? This is 0 degrees, so there is 0 degrees here. Okay. When omega increasing, and here in particular, we like to go to the corner frequency. For this case, the corner frequency is 1 over t, such that this trend become 1. Okay, so that kind of particular point we always try in a way. So in this way, this will be equal to 1 over square 2. Okay, and that one about 0.707. And then for this case, when T omega become 1, so basically that is minus angle of 1 plus J. And what is the angle of 1 plus J? So on the complex plane, 1 plus J is here. So that means its angle is 45 degrees. So here that basically is minus 45 degrees here. When this one go to infinity, basically this becomes 0. The magnitude is almost 0. And now for this case, that basically is equal to minus and 1 plus j multiplied with certain number infinity. What is this one? So basically this one is, again, this point right now is dragging to very top there. So that means making this angle corresponding to this point is almost 90 degrees, right? So now with this one, we can try to see in the complex plane. The real of the gj omega and imaginary part of the gj omega. Then the plot is this. So say from the beginning, say let me scale. So this is 1 and this is 1. Okay, let me scale the plot here. This is 1, this is 0 here. Okay. So for this one, this is magnitude 1 and at 0 degrees. So that is here. And for the second one, that is the magnitude, that is at 45 degrees. So 45 degrees is in these orientations. Okay. And with this magnitude, with that magnitude 0.07, so that would be something here, right? Okay. And for this one, when you go to infinity, the magnitude becomes 0 and minus 90. So basically approaching to is here. We have a point located at the lower portion of the imaginary axis, but this point is very, very close to the origin. So basically we converge to the origin from the bottom up. Okay, so that is here. And then if you do this carefully, you have more points, added up more points, then you can have the very good drawing. Basically, I can tell you this is a part of the circle. Okay, this is a part of the circle, and actually we can prove it, we can show it. This circle has at the center of 1.5. Here at the point 0.50. So right now this is the coordinate that is the center here. Okay, and radius equal to 1/2. And we can show it. Basically, you can try is this. You simply have these portions, and this will become the real part plus the j of, let me say this is alpha and beta. Alpha is the function of omega. Beta is the function of omega. And you can show it. Beta alpha minus 1/2 square plus beta square equal to 1/2 square. This is always true, doesn't matter the value of the omega. So from this one, we say this is a part of the semicircle because this actually is the equation for a circle, right? From that one, the circle with the center at 0.50 and with a radius 1/2. You can give it a try, it won't be hard. Okay. So that's for the second one. And we can start.